It doesn't really matter how accurate, intelligent, and sophisticated your AI voice agent or system is. If it isn't fast, the conversation will still feel broken and clunky. 1200 milliseconds for a response is the target we are looking for. That's the line between a conversation feeling natural and one that feels like the agent is taking forever to respond. And from experience, anything really above or beyond that 1200 millisecond point is when users start to get frustrated. They start to kind of check out mentally from the conversation, and in general the experience degrades a lot. You have to remember, when you're building an AI voice agent, you're competing with human conversation itself, and the response time is a massive part of the natural feel of a human conversation. And a lot of people think that latency is to do with what platform you choose, whether that be Vappy, Retail, Pipecast, LiveKit, any of these platforms, and that's kind of wrong. Most platforms have got the voice AI pipeline down. They've managed to reduce the latency of everything around the components very, very well, and they're all very similar in their speeds. The only things that we as developers can really control are the 5 components that affect speed, and those components are decisions to be made. Today, I'm going to show you exactly how to hit that target 1200 milliseconds consistently, and the specific choices and why and how those choices are made that actually move the needle, and how to build an AI voice agent that the responses and the responsiveness of it feels human. Okay, so these are the 5 components that affect speed. As you can see, we have speech to text, turn taking / endpointing, large language model, text to speech, and finally telephony. I haven't got anything written down for telephony. I'm gonna kind of just quickly, really briefly mention this because I think this is the least important one. And then finally, I'm going to go over my choices for these components. I will also talk about my choices for telephony. Let me add that there. Okay, so speech to text. Speech to text speed is very, very simple, and it's very similar to text to speech. You're going to have to choose the model that has the quickest and most accurate transcription speed. So this means that you want to choose a speech to text model that is built for real-time conversation. For example, one of the first good transcription models that was released, by far one of the best, and it was state of the art at the time, was OpenAI Whisper, but it wasn't built for real-time conversation, as it had no ability to stream at first. And so we want to find a middle ground between accuracy and speed. Now, obviously, I'm going to talk about the choices, like certain recommendations in a bit, or right at the end. But as you can see, I have a few logos here that you can kind of get a sense of potential choices later. Okay, so let's move on straight away to turn taking / endpointing. Like I said, speech to text is very simple. There's not much you could do. Okay, so these 3 platforms, we've got LiveKit, Pipecast, and Vappy. They all have their own turn taking / endpointing models. So Pipecast and LiveKit are both open source, and Vappy is only like the Vappy turn taking model is obviously only on Vappy. They haven't open sourced it. And these models, in my opinion, are likely going to be the future. My guess is they will become the standard and only approach when it comes to turn taking / endpointing. Now, there is another alternative, which is transcript / VAD based endpointing. And by the way, I will get back to the turn taking models in a second, but let me go over the alternative first. And the alternative is a lot simpler. So the endpoint happens, and the latency of the endpointing is all to do with the punctuation. So how it works is, let's say there's some punctuation, like a full stop, an exclamation mark, a question mark, or a colon. That's going to cause an instant trigger for the LLM request. So when the transcript, let me go to no punctuation. So if there's no punctuation, we can wait X amount of seconds. This is just because the transcription model will not do a punctuation if the sentence is likely not finished yet. So if we look here in the examples, hi, do you know, and then there's no punctuation, this is likely not to the end of a conversation, and so we wait maybe 1.5 seconds, maybe 2, maybe 1. This is kind of up to us, and it's configurable. Then if we had something like, hi, do you understand me, with a question mark, this has punctuation, so it's going to be an instant respond or an instant endpoint to the large language model and allow the pipeline to carry on. And as well as if it's a number, we might have like an in-between. So I don't know, maybe wait half a second, because someone might say another number, but if someone's talking numbers, then they're probably going to say the next number pretty soon and quickly. So, half a second to wait is kind of a good in between. Now, this is fast, and I'll explain to you why it's so fast. It's because there's no additional model. So what we're doing is we're just getting the transcript, and then based on what the transcript is giving us, we are adding time to wait or to not wait for the large language model and then text to speech to carry on. So we're not adding any additional model, which is exactly what we're doing with the turn taking / endpointing models that Pipecast, LiveKit, and Vappy have. So this basically means that there's no extra latency, except obviously the wait time that you set. So if there's no punctuation, 1.5 seconds, etc. So trained models are a bit different. So a trained endpointing model, which is the first things I talked about, looks something like this. So they'll get the input, just like you input into the punctuation base, the transcript. You're going to do the exact same thing, but send it to another model. So just literally just think about it as sending to an LLM, because actually a lot of these endpointing models are LLM based, like they're really small models, fine tuned. And so something like "Hi, do you know?" is going to be sent to that endpointing model, and then the endpointing model is going to give it a confidence score of how confident it is that that is the end of the person's conversation or the end of the person's utterance. And so, for example, for something like "Hi, do you know?", it's very it's very likely that the user hasn't finished speaking. So as you can see, the confidence score is very low, 0.08. So because it is low, we're going to keep listening for X amount of time. This is usually some sort of calculation. So if the lower it is, the longer we wait, the higher the confidence, the shorter we wait. Compare that something to "Hi, can you hear me?" ? The output is going to be a very high confidence because it's just very likely, and the endpointing model distinguishes the difference between the end of a conversation and not the end of the conversation, and it does it more semantically and on many more layers than just punctuation. So it is more accurate, but it is another request to another model, and that does incur more latency. But you're going to have those smarter endpointing decisions. So I think I might have missed a little bit at the start here, where I just kind of want to say why turn taking / endpointing adds latency and affect speed. So essentially, in the pipeline, once the voice goes through the speech to text, and like I said, this is very simple. You just choose the best, fastest, most accurate speech to text model, and once that transcription has been sent to the turn taking / endpointing part of the pipeline, we now have to wait or not wait a certain amount of time to allow for the next part, which is the large language model to the text to speech generation. So if we're waiting no time, so as soon as the speech to text has kind of realized, look, we are finished with the transcription, we start sending the request to the large language model and text to speech, then we're going to have zero latency in the turn taking / endpointing. But with something like the trained models, we might have latency added in order to not false trigger the response from the large language model and the text to speech when the user hasn't finished speaking. So that's why the turn taking / endpointing adds latency, and we have to consider VAD based versus trained models. And VAD based stuff or transcription based stuff, which is like not the trained models, is quicker but less accurate. Okay, next let's go to large language models. So the most important metric we are looking for in LLMs with speed, in Voice AI as well, is time to first token. We are much less worried about tokens per second, as essentially all LLM models are, in my opinion, fast enough. The only time tokens per second really matters are during function calls, and sometimes they can matter, and they make like a really minute difference, I guess, for streaming the response to the text to speech, but it's very minute, and I would not worry about it. So I'll give you an example of why it does matter actually for the function calls. So let's say we're mid function call, update user preferences, user ID equals John D, and then we've got a few dots because we haven't finished it. This function call obviously won't trigger. So we want the function call and what the LLM wants to do to be outputted quicker. So if this is the entire function call right here, update user preferences, user ID is John Doe 123, theme is dark, notifications enabled equals true, language equals English GB, time zone Europe London, and currency equals GBP. So at this point, this function call would now fire. Once it's fully done, and fully outputted. So this function call, this update user preferences, is 36 tokens long. So imagine if the LLM was doing 1 token a second, which is obviously not what LLMs are doing. This would take 36 seconds to be fully outputted. So obviously this is an extreme example, and we're lucky that LLM models aren't that slow, but you can kind of see how tokens per second do matter with function calls. Now, essentially all models are around 100 tokens per second. Sometimes they can be a little lower, like 50, but it's quite rare. And most are above. So, Cerebras can go up to, 2,300 tokens per second, which is really, really, really fast. Okay, so let's go back to time to first token, because like I said, that's the more important metric for the latency and speed when it comes to voice AI agents. So the best providers for really good time to first token times and consistently is by far Grok, Cerebras, Together, and Cohere. These providers are all providing, so Grok, Cerebras, and Together are all providing inference for open source models. Or sometimes they might have partnerships with non-open source models, but that is quite rare. And yeah, they're essentially providing inference. What they do is take open source models, download them like you would of Hugging Face, of whatever the model is on, run them on their hardware, on their, infrastructure, and then allow you to use that inference at a cost. Just exactly like OpenAI is doing, but with their own models and with their own infrastructure, with their own hardware. They're only doing it with open source models. And then Cohere, which I also mentioned, which has incredible time to first token, some of the best, provides the inference for their own models, just like OpenAI, but the models, aren't the best at the moment. In the future, when they release one, they might be better. But right now, they aren't that good and they're quite expensive. But they have really, really good time to first tokens. The reason why providers like OpenAI, Anthropic, and let's say Grok haven't got as low of a time to first token is mostly a traffic and like hardware issue. So I'll give you an example. Actually, Google has pretty good time to first token. The reason why I have Google have really good time to first token, or decent, not as good as these, but better than these, is because they have a ton of hardware and they have not as much traffic to hardware ratio as OpenAI or Anthropic. And because of that, they can offer a better time to first token. So OpenAI, Anthropic, have tons of requests. I mean, OpenAI and Anthropic are getting tons. I mean, just imagine how many requests are being sent to Anthropic through Cursor, through Claude Code, etc. OpenAI is the same. They have Codex, they have their ChatGPT, right? That still sends to their infrastructure and to their hardware. Same with Anthropic, they just have Claude. Grok has the same. And they don't have enough hardware to supply all those things at a low time to first token, and there is basically traffic issues. Here is kind of what I was saying. They have ridiculous amounts of traffic and simply don't have enough hardware and compute to offer such quick time to first token that companies like Grok, Cerebras, and Together can offer, as these companies only offer to the market. Their offer to the market is fast, consistent inference. OpenAI and Anthropic, their main selling point as a provider is not we have incredible time to first token, or not just incredible time to first token, but like really fast inference. Their offer to the market is we have the best models. They're closed source, which is like we can only provide them. So we have the best models and we can only provide them. So you have to come to us. We're relatively cheap, let's say. We have the best coding models, wherever it be. We have ChatGPT. That's their offer to the market, rather than Grok, Cerebras, and Together. Their offer to the market is consistent and fast inference. And so that's why they have better time to first token speeds and token per second. So I'll just quickly go on to like artificial analysis and just show you something. So if I were to go to providers for a model, and we'll just take the most basic model like Llama 3.3 instruct 70 billion, open source, and is provided by probably all of these, definitely provided by all of these inference providers. So if we were to take a look at these providers, you can see here we have output speed versus price, let's say. So, some of them actually offer different prices because it's an open source model. So there's no one person setting the price of the model. It's more the market sets the price, and the companies that are providing the inference set the price. So as you can see, output speed versus price, we have Cerebras completely in the top right corner. They're the most expensive, but their tokens per second speed is like 1200. which is, I mean, sorry, not 1200, 2200, which is insane. Same as latency versus output speed. Again, really low latency. But if we scroll down a bit further, we can go to time to first token, which is, you know, a very important metric for voice AI. And we can see Google Vertex actually has the best. But I looked for Google Vertex and I don't see the Llama 3.370 billion offering anywhere. So maybe that's something older. But as you can see, Grok has 0.21 time to first token. And I've actually seen time to first token even at like 0.98 milliseconds when your network latency is good. So Cerebrus is over here with 0.29, which is not a big difference. Anything really under 0.35, maybe 0.4 is a very good offering, and you know, pretty good for voice AI. Obviously, the lower the better. That's why we also have Together AI here. These all have pretty good latencies, and they're the easiest to get up and running. Grok, Cerebrus, and Together are the easiest to get up and running. You know, Friendly AI, Snowflake, Lambda, Deep Infra, they're all a bit more confusing to get up and running. Samba is pretty good as well. I just don't like it as much for whatever reason. I'm not even sure why, to be honest. So yeah, that's time to first token, and you know, a very important metric for voice AI latency. Text to speech, like I said, it's very simple and similar to speech to text in the sense that all you're going to choose is the model that has quick generation. So how quick can it generate the audio from text? And then, you know, how like quality is it, like how good does it sound, right? Those are the two metrics. Kind of like with the speech to text, we had, you know, how quick is it and how accurate is it. This is how quick is it and how good does it sound. So this means that like OpenAI Whisper isn't built for real-time conversations. You know, for example, 11 Labs V3 is also not built for real-time because it has amazing realism and quality, but has bad latency. So, you know, we want to find a middle ground where, you know, we have realism and speed, and that model is built for a real-time conversation. Okay, so telephony. Obviously, telephony matters. There's extra latency, like, you know, the latency on the web. So, I don't know, Vapi has their own built-in like latency estimate measure. And if you were to have the latency of this, which is using GPT-4o, DeepGram, Vapi for the voice, and the transport being in the web, you can see around a 1 second latency. That's their guess. But then you add the provider instead of a telephony provider instead of the web, and now you get an extra 600 milliseconds of latency, which is a big difference. And so they estimate Vonage, for example, is actually only 400 milliseconds added latency, which is, you know, kind of what we're talking about. With telephony, you simply want to look for the providers that have the lowest latency. So some good providers of this is Telnix. I think that's how you say it, Telnix. Vonage have good latency. Twilio is probably the slowest, purely because they're just dealing with so many customers. Their infrastructure is a little bit less private. And so, like, I mean, really, those two are good enough. And I'm sure there's many more providers out there for telephony that have really good latency. It's just something, again, similar to speech to text, where it's just like, you want to find that thing, you just search up lowest latency telephony provider, and that offers SIP trunking, which will be every one of them, and you basically decide and choose that. But I think Telnix and I mean, look, you even got 4 voice agents, so Telnix and Vonage are pretty good. You know, I would go for them quite often. Like, as you can see, Telnix is mentioned here, and overall they are very good for VoIP and telephony latency. Okay, so let's talk about my choices for these components. And then actually what I'll do is just go into Vapi and talk with an agent that has kind of average latency, and then one that has taken all my kind of components and choices and logic and the things I've mentioned, and just show you the differences in latency and how it feels in a conversation. I'm going to talk gibberish to it, basically, like I'm just going to say hello, 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 whatever. But you can just see the difference in latency and how that affects the nature of the conversation. So my choices for these components. Speech to text, I think really good ones are DeepGram Nova 3. I think you just can't go wrong with DeepGram Nova 3. It's very fast. It's highly accurate. DeepGram are always, you know, pushing. DeepGram Nova 2 was very good at it at the time. DeepGram Nova 3 is very good at its time. And so I just think it's a good provider to go for, and, you know, don't want to overcomplicate it too much. It's a good choice. Same with Cartesia Sonic Whisper, recently released. I believe it's just OpenAI Whisper, or I can't remember exactly. I think OpenAI Whisper was open sourced, and so they've done this. Like they've taken Whisper and basically made it like for real time. Like they've you know basically changed it to a real time conversation base or like real time voice AI. Kind of compatible speech to text model, and it's again very accurate, very fast, and a good price as well. Then we also have Assembly AI, universal streaming. This is again based for speech to, like the speech to text is specifically based for streaming and real-time conversation, which makes it low latency and relatively accurate. So these three are what I would choose for speech to text when it comes to speed and accuracy. Okay, turn taking slash endpointing. So the choices are kind of like there's not many choices here, so I've kind of mentioned all the choices. So the best for latency is by far punctuation based, because it's just going to be more aggressive, and so that is a good thing. But then it might interrupt like thinking. So if I were to say something like, "Hi, I'm right," that's obviously transcription based. It's not going to have a full stop because the transcription will know, okay, we're not going to transcribe the full stop there because we don't think the sentence has finished based on the transcription training the model has done. But 1.5 seconds, for example, isn't that long. And, there's a different level of confidence to that and to something else. And so that's why it might be more inaccurate and might interrupt thinking more often compared to something like LiveKit and PipeCat. For LiveKit, I would always put it onto aggressive. So it has some options. If we go over to start speaking plan, you will see that LiveKit has some options. So you can put it on aggressive, you can put it on normal, and you can put it on conservative. I think you should always have it on aggressive, purely because I think the model is quite conservative naturally. And so I would have it on aggressive because I think it takes too long anyway. I would even make it slightly more aggressive if you do some learning about like this logic over here. And so, yeah, that's a good choice. And then we have the PipeCat model. Now, the PipeCat model isn't available, and I don't recommend the VAPI model just because it's just like, it doesn't seem to even work really. And I wouldn't, I just wouldn't recommend the VAPI model. And the PipeCat model is good, but for the PipeCat model, you can't do that in VAPI. You can't do that in Retail. You can't do that in Bland. Not many providers, like basically no platforms offer it except for PipeCat, even though it is open source. So maybe in the near future, VAPI will add the PipeCat model to the start speaking plan. In fact, I think they will. So, then we will kind of have more access to that model. Okay, so the large language model, now this is probably more important for most people since whatever platform you're on, most platforms give you the choice for a lot of large language models, and a lot of them give you the choice for a custom LLM, which is where you can implement essentially any large language model as long as you're formatting it for the way that they want it. So my choices would be Qwen 3 235B 2507 Instruct. Like, I know that's a annoying name for the model, and Together AI offer it. In the near future, hopefully Grok will offer it, and Cerebrus does offer it now. This is like happened. I don't know. I just didn't even know about this until I did some research. But yeah, Cerebrus does offer it now at a crazy latency. In fact, let's just go and take a look. Let's go here. Cloud Cerebrus. Again, like it's gonna have like 500 tokens per second. Hello. Yeah, as you can see, we're on the Qwen 235B Instruct. We can run it, and I mean, time to first token is not too good, but the tokens per second is crazy. So if I were to say, give me a huge story, I misspelled it, but look how quick it is going through. I mean, that is insane how fast the response is. And the time to first token was pretty good there as well. I think they have a metric for that. Let me just take a look. Inference time. Interesting. I don't think it does say, yeah, it doesn't say how quick the first token was, but I'm sure it was probably in the first like 0.3 seconds. So as you can see, very, very fast. But one issue with Cerebrus, which is kind of annoying, is that they have pretty low quota. So that their usage limits are pretty tough. You only have 30 requests per minute, which is not very high. I mean, one conversation would probably be doing maybe like 10 requests per minute, I would say. So that's one concurrent conversation on VAPI. or on any platform would be using around 10 requests per minute. And so if you will scale that up to 3 concurrent conversations, you're kind of done already with Cerebrus. Now, they do have the ability to, ask for higher rate limits. So you can tell them about your project for a potential upgrade. But this is quite rare because Cerebrus are pretty enterprise. Like, they only really offer really good inference, really high RPMs, really high limits to very enterprise customers. So that is a bit of an annoying thing. Together, on the other hand, have very good rate per minute. Like, they offer a lot of inference for a lot of people, but it's slightly lower tokens per second, and the time to first token is a little bit lower. And hopefully, and I believe they will, in the near future, we get Quen 235, Quen 3, 235, 2507 on Grok, because they have very good time to first token, very good inference, very good limits, very good pricing. And so I think, I would probably use it on Grok in the future if I could. Another choice, Kimi K2 on Grok. Again, low time to first token, very good model. So if we were to go onto artificial analysis.ai/models, and this is a blessing, the new kind of non-reasoning models from China have kind of saved us, because for a while we've been stuck on essentially GPT 4.1. The new Llama models were terrible. And so we've kind of stuck on non-open source models for a while. And now we're back to open source. We're back to better latency, because now those inference providers can offer them. And that is a big, big blessing for us. So as you can see, the Quen 3 model is better than every single other model, even closed source models. So let's take Claude 4 Opus, which is the most beefy non-reasoning model by Claude, and as you can see, it has a lower intelligence index. So that is absolutely amazing, and you can get this fast, better than Claude 4 Opus, and cheaper, which is just insane. So well done, China, for that. And Kimi K2 is also very good. As you can see, it's on par, just slightly below Claude 4 Opus, which is more than good enough for voice AI agents. And as you can see, it's better than 4.1 and 4.0, which we know are very good models. So we can put our trust in Kimi K2 and Quen 3 235 B2507, I believe. Like, I haven't done crazy tests on these models yet. We're slowly rolling these out for clients, but I still haven't got crazy amounts of data in the field, but I believe they're going to be good, especially from my vibe testing. They seem to be good. And then obviously we do have OpenAI. I do want to mention briefly OpenAI GPT-4o and 4.1, specifically on VAPI. They've optimized the latency of these models very, very well. Like surprisingly well. It kind of goes against what I said in this with OpenAI and Anthropic not being able to offer low time to first token. And it is true because of the traffic. But what VAPI have done is essentially tried to remove the traffic issue by sending your request to certain servers of OpenAI at the right time. So I think they have a blog of this. Let's just do VAPI blog. I'll quickly show you. So here we go. How we solve latency at VAPI, and it's all talking about GPT-4o and OpenAI specifically. I think that's probably their most used model on VAPI, so that's why they tackled that problem first. But they have essentially, they went through a process and they've added some code to essentially reduce the wait times, and I believe they reduced it quite a lot. I think there's a stat somewhere here that they reduced it by 1,000 milliseconds. Yeah, here we go. So the system that they built shaved over 1,000 milliseconds off our P95 latency, which is the problem again with OpenAI, which is like you don't have consistent latency, because there are moments where there's no traffic and there are moments where there's a lot of traffic. And so yeah, VAPI have optimized it pretty well. I think Retail have done a bit of optimization, but not as well as VAPI. And so yeah, it's actually a decent choice, because you're going to look at like 300 to 500 time to first token latency, or 300 to 500 milliseconds of time to first token latency, which is relatively decent in my eyes. And obviously they're very good models too. But I mean, Quen 3, just a very good model and fast. So yeah. Okay, next, text to speech. My choices for text to speech would be Rhyme AI, Arcana / Miss V2. They're both very good models. Arcana, don't know how to pronounce it exactly, is the more recent model. It is very good, but I've had issues like on VAPI, Rhyme doesn't even work. on a lot of providers, sorry, Rhyme doesn't even work, but it is a very good text-to-speech model. So when it is working on those platforms, once the deployment is kind of working properly, this will be a very good and hard to beat text-to-speech model and provider. Then we have 11 Labs, and obviously text-to-speech obviously matters. If I'm talking specifically English here because English is the language I speak. English is the language that I provide for my clients. I don't do work with other languages because I think as a voice AI developer and my team, we need to have an understanding of the language that is the root. Like I understand English and I know how difficult it is to prompt whilst knowing the language. So imagine if I didn't know the language, I think it would just be terrible. And so that's why I don't offer non-English implementations. So 11 Labs Flash Turbo is also very good. It is more expensive, but it is very fast and it sounds good. So it would be a choice for text-to-speech too. Like obviously all of these choices are up to you. You're going to have to do a bit more research for them, but these are really the 5 that I'm looking at. Cartesia Sonic 2.0, also very, very fast, very good for real time. Cartesia is all about real time conversation and providing the stuff for that. So they're a very good choice to go for. Like mid-market price, like they're not the cheapest, they're not the most expensive, and the voices mid-market to good quality, so they are a very good choice. Now Minimax Speech O2 Turbo, this is in my opinion my favorite voice model there is. I've played around with it in the playground, and it just sounds natural. It sounds conversational, and I just like it as a model, but not many places provide it. Vapi have recently added it into their UI. So if I were to go here, you can see Minimax right here, and we can go Speech O2 Turbo. I wouldn't do HD because the latency is too high, but Turbo is good. You can add your own voice ID, so you can just do that in the Minimax platform. So English Diligent Man is a voice ID, but unfortunately it's not working right now. As you can see, error updating assistant. You have to provide one of the other platforms. But Vapi always does this for some reason. So my guess is that the Minimax model will work in a week or so. Next, yeah, and it's just very good. So, and it's relatively fast, it's relatively cheap. And then Vapi also have their own model, and I do think it is very good. I've not used it in production because I don't know how stable it is, because they had to remove certain models because they weren't stable enough, which is a bit of a scare. I would rather not have any models removed because they're not stable. But it sounds very conversational. It's very fast because they have it, running on premise is my assumption. But anyway, even if it's not on premise, it's very fast. And it's relatively priced well. Like as you can see here, we're looking at 0.02. Okay, cool. I think that's it for the video. I hope that was pretty useful of an explanation of how to build the fastest AI voice agent. Obviously, not only do you want to build the fastest, you want to build the most intelligent, accurate, like I mentioned at the start. Those things are extremely important, and yet speed is so important.